Hello all, previously we have seen how to delete a node at the beginning of a double linked list. Now in this particular video we will see how to delete a node at the end of a double linked list. So we are using a user defined function called delete at end, which is not accepting any parameters. If head double equal to null, that means the linked list is empty. We have nothing to delete in that particular linked list because linked list is empty if head double equal to null means. For suppose there are some nodes in the linked list, then what is the scenario? We have to declare one temporary pointer which is pointing to the head node. Instead of going through each and every line of the code, I will directly take one example and I will explain with that example. That would be better, right? So I will take one example like this. I will trace the function each line by line. So that will be better. So for suppose the linked list is as follows. We are having 4 nodes, 1, 2, 3, 4, and head is pointing to the 100th location. That is the first node. That is the beginning of the linked list. I mean double linked list. If head double equal to null, is the head double equal to null, head is pointing to 100. So head double equal to null is false now. So this if condition will be skipped. Okay. What if head is null? That means the linked list is empty, as I said earlier. Okay. So now I will take one temporary pointer called temp and I will point to the head node itself. So head and temp both are pointing to the first node. That is the meaning of this line. So the updated linked list as follows. So head and temp both are pointing to the first node. Okay. Now if only one node is present, for suppose in double linked list only one node is present, what it signifies? So head next is equal to null. Head next, it will be null, right? If only one node is present in double linked list, the next part is also becomes null, right? In that case we can delete directly that node. We can directly delete that node, but in this case the head next part is not null. It is pointing to some other node. So this will be skipped. Okay. Now we have to traverse the temp pointer to the last. So we have taken one temporary pointer, right? And we have point to the first node. Somehow we have to traverse this temp pointer to the last node. So how do we do that? By using while loop, we have to traverse it. You can use any loop of your choice. Temp next. What is temp next value? 200. What is temp next value? 200. So temp will move to the second part. Temp will move to the second part. I mean second node. And again, what is temp next value? Temp next value is 300. Is 300 not equal to null? Condition true. Now temp is equal to temp next. Temp next is 300. So temp will move from second to third. The updated diagram as follows. Initially temp is at second location. Now temp moves to the third location. And subsequently temp next is equal to 400. Is 400 not equal to null? The condition true. Temp will moves to the next location. So initially temp is at third location previously. Now temp will move to the fourth location. So after this third loop, after this third iteration, temp is at the last node. Now condition check will happen one more time. Temp next is null. Is null not equal to null? It is false. While loop is terminated at this point of time. So updated diagram looks as follows. Head is pointing to the first node, temp is pointing to the fourth node, that is the last node. Now update the second last nodes, and that means second last node, that means last but not one node, that means the third node. That is the meaning of second last node here. Next pointer, we have to update this pointer, that is what they are saying. This 400, there is some modification with respect to this place is must be required. How to do that? Temp arrow prev arrow next. This notation is somewhat similar. So let us try to execute line by line. So null, we have to somehow goes to the third location and make this 400 as null. How do we do that? So temp, where is temp? Temp is at 400 location. Temp priv is 300. So we have to move to the 300th location. 300 next is 400. In this 400, null should be assigned. So after this line, the linked list is as follows. So in this 400, null will be placed. That means the forward link will be missed. The link between third and fourth will be missed. But fourth and three, the link is present. Now we can simply delete the last node by using free temp. That means we can delete this temp node directly. The updated diagram looks as follows. We have deleted the temp node and third node becomes the last node. See this this into represents the null value. So that is how the delete at end of the double linked list is performed. Now let's try to execute this code in DevSweep IDE so that you will have a better understanding. So initially we are adding 10, 20, 30 in the double linked list, and before deletion, what is the linked list? I am printing that with the print list function, and we are deleting at end. That means 30 will be deleted, and double linked list after deletion at the end, we are again displaying the function. And don't worry about delete at beginning. If you want, you can delete at beginning. Now in this particular video, our point of concern with respect to delete at end function only. Okay. So after deleting the node at last position, what is the linked list? That is what we are interested in here. So execute. By the way, if you want to see the code, I will show you. So whatever we have written in that nodes, that is there here. Now let us try to execute this code. Execute, compile and run. We don't have errors and warnings. Before any deletion, 10, 20, 30 null, that is the initial linked list. After deleting the node at end, 30 got deleted. See here, 10, 20, now 30 got deleted. So the beginning function I have called later. Now 10 also got deleted. So this is how delete at end function will works. So let's see the other example in other video. So in my next video, I will tell you how to delete a node at specific position in double linked list. Thank you so much for watching.